Okay, so for everything here, there's about a 15-second delay between when OBS sends it out and YouTube receives it. Okay, so this usually is an indication that I'm going to be doing something ridiculous today. And indeed, I am going to be doing something ridiculous today. This is... Notice by the way, my focus is weird here. We'll explain to that. So this is my Weller 8200, 140, 100 watt soldering gun. And we will be doing some recapping today. Now, how am I going to explain this? This is not my first foray into having to deal with older electronics. And we're talking old electronics. I'm just going to quickly shift off here. Actually, let's not do this since there's no one really in the stream yet here. I'm just going to go and grab the unit. In a nutshell, we are going to be recapping this today. This is basically all the electronics to a Webster Model 80 wire recorder. It's from, what was the date code on this thing? It was like 1947 or 1945. It's 80 years old at this point. You are going to run into this problem a lot with a lot of... Hello, Starlight. You're going to run into this problem a lot with electronics from this era, and honestly, even up to the 1970s, are these little suckers right here. So, if you don't know what this is a capacitor. At this point here, they may have even still been calling them condensers. But it is a paper tube with the foil and paper insulators inside, and it's sealed in wax. This is very early capacitor technology. We have long since gone away from this style of capacitor because you can measure its mean time before failure in hours to hundreds of hours. These are terrible caps. 80 years later, they're junk. So we will be replacing them with modern equivalents. This is where some people get really annoyed because... now, this is not a museum piece. I will assure you this is not a museum piece. So I don't care how I recap this thing. I'm not going to go with each cap, hollow them out, burn off the wax, and restuff them with modern caps for nice looks, because I don't need that. I am not going to find exact replacements for these caps either, because while there is people in the audio amplifier, most notably the guitar amplifier world, which will replace wax paper caps with modern wax paper caps, those people are crazy. We're just going to be replacing these with, for the most part, metal film and polyester. It also drastically brings down on cost when we don't deal with exact values. Some of these caps here are 400 volt. We're going to use 600 volt versions of them. So that also drastically brings it down. And for the purpose of this video, I will not be doing the lytic cans, which I've already removed, because those actually have to be cut open and restuffed. And as it turns out, actually, I made a mistake here, so it's not even ready to be installed anyways. I made a tweet about this last night, so let me get this out of here. This, if the light wants to behave with me, this is a 1 microfarad, 200 volt DC paper capacitor. I thought this was an electrolytic capacitor. No, this is not a multi-stage capacitor either. This here is just one cap. One cap. It's also bipolar. There is no polarity marked on this cap or on the schematic. That was my mistake. Because I said that this little buddy right here, which is a 1 microfarad 250 volt lytic, was the same as this. I'm sorry. That I was wrong. I made a mistake on that one there. This cap here, you can't use to substitute this, at least on this application. What might be more practical is this. This is a 2.2 microfarad, 250 volt polyester film capacitor. Even this is double the value of this. So I have to do my math to verify if we can do that. And that's another thing with a lot of these here, is that when you deal with capacitors of this age, your tolerances are just insane on how far you can drift up or down. Don't go down with voltage, but like, let's say you have a 0.5 microfarad capacitor, you can use a 0.47, for example. Like, it'll let you drift like that, and that's fine. And in this situation here, it's even more fine. We're not dealing with a precision oscillator. We're not dealing with, like, calibrated sources. We're dealing with nothing. This is just an amplifier for both record and playback on the wire recorder. That's it. So as a result, I kind of did some fudging. I did some math. We have a pile of caps here that this is too bright. Damn it. Let me turn the light off here. There we go. That's just going to replace most of these. I don't know how long this is going to take. This is also my not the first time I've had to deal with this. Let me just switch away here briefly. So, going back almost 7 years ago, I had a TV I was working on. This is a Westinghouse 17 TV7C. It is a black and white set from 1954, made in Canada. In my family, my grandfather was a Westinghouse repairman for many, many years. So this kind of falls in line with stuff that he was working on. So I kind of had an obligation to rebuild this. And as it turns out, this turned out to be absolutely fantastic. The tube was okay. I did have to change a couple vacuum tubes. The recap took like 2 weeks on this thing. So what we're doing here today is not going to take anywhere near as long. But it came out fantastic. The cabinet was redone. Everything was polished up. The knobs were done. And it looks fantastic. And it works. I do have to go back into it because it keeps losing vertical hold once it warms up. But it looks significantly better than what it was. What we're working on today is this. This is the Webster Chicago Model 80. This is not a museum piece. This cost me $80. So it's also not too expensive as well. I picked this up back in last year of 2021, but I wasn't able to pick it up until February or March of this year because of that whole thing flooding out all the local highways last November. But it's here now, and the initial testing that I had with it, I just quickly set up a variac and a dim bulb tester, and it's got ridiculous amounts of AC hum, but nothing immediately wanted to explode on it. Nothing immediately was overheating. So this is a prime candidate to recap. So we are going to do exactly that today. And I'm also going to quickly play show and tell here as well. That dim bulb tester, even that thing that you see there is obsolete, because after that I was like, this is ridiculous. I need to build something a little bit better. So this is the, can I seriously make this dimmer? Hold on a second here. There. So this is the dim bulb tester I made after that. Everybody makes their own version of the dim bulb tester. In reality, what it is that you can just ignore all of this. You just have a plug, an outlet, and on one side of the wire, usually your hot side, you have a light bulb. And the idea here is that heavy loads will be restricted through the resistor that is the light bulb. And if you have a dead short, it's going to try and dump all that energy of the short into the light bulb, not into whatever you're testing. Everything over here is just kind of like premium features. So on the load side of the light bulb, I can see what the voltage is, because as the resistance inside the bulb changes, the voltage will change as well. I have this little fancy thing here, which allows me to run it in the dim bulb mode, turn it completely off, and there's a momentary switch, which lets me bypass this altogether and just run 120 volts straight to here. And this is also a complete option here. I have a little socket over here for a kilowatt. I don't even need to have the kilowatt installed to plug this in. But this then lets me monitor my amps, my watts, obviously, and my line voltage, not my load voltage. And this whole thing isn't complicated. There's nothing in here. There's no transistors. There's nothing like that. I think the most advanced object in here is the voltmeter. And this will do 15 amps, though heavens forbid you actually put 15 amps of load through this here. Usually it means you're shorting something out. So, enough procrastinating. Let's get to this. So, I am just going to kind of look up caps that are on here and begin pulling them off and switching them out. I'm not going to be doing an excellent job at this. Again, it's not a museum piece, and it's been a few years since I've done this. No music will again be provided today, just simply because I'm still struggling to find the music that either A, I like, and B, doesn't set off YouTube. And if we run into weird focusing issues, that's just the narrow depth of field. We're at like 12 inches from the camera up here down to here, so it is kind of narrow. Where did I put my solder? 0.01600 volts. I may also run into some hilarity here because some of the caps I bought are not going to have long enough leads, so I may be trimming some of these as well along the way. Let's see. So you go to the microphone, and I think that's the power switch as well. I also have no idea if this is going to be clicking the audio or not. We'll see. Oh, right. We're going to be running into that as well. So, even though these caps here are wax paper and all that, they do denote ground. They do all denote ground. Our modern caps here do not denote ground. Many of these will not indicate which side is ground or which side is kind of the outside foil. This is something that's open to a lot of debate. There are situations where this does matter, especially in sensitive audio circuits, and it can cause for inductance and hum. This is probably going to come back to bite me. I will admit that myself, because I didn't look that up. There's only one cap on here, though, where it specifically may be an issue, and that's this one right here, which is all fuzzy and awful. This one actually has the outer shell grounded, and I have no cap to replace that, which is also grounded. Because it's so far out, like where I can reach it, if I run into a problem, I can figure out a way to shield that later. But if it's one of the other cans, which are way the heck in here, let's deal with that. So I'll do this, and then, yeah, we'll just go from there. And as for polarity, if I have to deal with polarity, I will. Otherwise, either way will work. Where the heck did it go? enough in there now. Nope, hole ain't big enough yet. Yay. What is shifting around here that won't let me put that back in? Okay. Can I get a lead in there now? No. Oh, this is going great. There. Okay. We will probably need those later. Okay, 0.05, 600, 0.01, 0.02. U. If I can pull the solder out of some of these, they're a lot easier to unhook, because I think with the exception of this one Cornell Doublier right here, this is all original. So this was all nicely wrapped and hooked in before it was soldered. And then there's this Cornell here, which is J-hooked. Wrong tool for the job. I'm just going to cut the cat loose right now. Ow! And I'm going to poke myself with it twice. Okay, how am I going to get this out? It's always a bit of a puzzle when you're doing this. Not so much a game of operation, but like you run into these weird... Okay, there, I got a cold joint on it now so I can cut it in half. It's a weird game of operation whenever you do this. Point-to-point wiring, I mean, on paper, it looks great. And we do have the schematic for this, by the way. Point-to-point wiring is great. But when it actually comes down to actually doing it, when you have weird angles like this, where you couldn't even see what I was doing, could you? Where you have these weird angles, like, it becomes a nightmare. This cap here is going to be hard. The lytic that's way the heck here behind the transformer, that's not going to be part of this video. I still have to work on that. Okay, so you went there. Come on. I see you. While I'm in here, I might as well also get this cap ready. Ow! Moo, hey Moo. Hey Paul. Sorry, Paul, like, I'm dealing with a very narrow... Here, let me try this. Like, this is the edge of the desk here, and this is the backmost portion of the desk. I do apologize if it's very out of camera or just terrible angles here. I will try my best. But at the same time, try and keep an eye on the corner of my eye over here, where I can actually see the display. But thanks for the heads up. Okay, you can quit giving me grief at any time now. There we go. And you are a 0.01400 as well. I think that'll do. I see you about to give me grief. I keep grabbing the wrong soldering iron. Oh, I hate these nested ones. There. Okay, I'm going to clean that one up after I solder it in. I need to be saving these leads here for later, so... That there is a nasty recap. Like, I was so sloppy on this one here. I've actually almost torn the arm off of this potentiometer, but it hasn't completely torn off and I've soldered it in. It just looks ugly. It won't actually affect anything. Okay, now I have this one here. Which goes way the heck up into here. I'm expecting to have like a spot over here where I can put the iron, but I can't because my desoldering iron lives over here. So I'm going to keep expecting to grab that one over there, but I don't. Another thing I didn't spend too much time doing yet was testing to see if all of these carbon resistors were still good. I tested some of them. They seemed okay. So the key word here is it's close enough. Oh, except when I do that. There we go. Okay, I see the other end of that cap lead. Now it's a case of like getting it bent outwards so I can unwind it. If you are watching this and you do this kind of work for a living in 2022, I commend you because this sucks. Like, to be able to undo these J-hooks and all this and actually make this look like not garbage, that's difficult. Now, it doesn't mean this is poor serviceability. No. These were designed for serviceability. Notice the complete lack here of quad flat package surface mount devices. This is... I know this varies from person to person, but for me, this is easier than dealing with surface mount. This is an inequivalent to what I was being trained on in high school. And even then, like, this kind of wiring method was completely obsolete. But instead, we made an SCR switch circuit, and it was just little tiny brass nails tacked into a piece of wood with a little schematic overlay. So you could visually see how it was wired. This is another one where I can't get the hole cleared out again. But I'm trying not to drift these resistors. Oh, I'm an idiot. There's actually a hole in the bottom of it I've cleared out. Ow! So what's the difference between J-hooking in and wrapping around the caps, the cap leads when you do these terminals here? From an assembly perspective, if you actually wrap them through each terminal and lead, it just looks a lot better, and it's a much stronger bond when you go to solder it. When you go to repair, however, it's okay to J-hook because you're never going to get a lot of the solder out, and you have a lot of components now clustered in there, plus that. Could you please not get in here? Hold on, let me do some maintenance. Okay, what was that? Let me tell you, when it was tube radios, it was love at first sight. Where was I? I've lost my train of thought here. Let's just get back to recapping. Oh, yes, J-hooking. The J-hooking is fine at a repair perspective because there's so much stuff clustered in here along with the solder. What you do not want to do, however, is just kind of lay the lead over the existing ones and then just tack it in. Or worse yet, J-hook it to other components in the same terminal, because then if they ever have to be moved or something happens and you get a poor bond, like that lead will pop off and you will have a terrible solder joint. Okay, there's that one, there's that one. Okay, so there's two more. There's two more done. There's another 600.01 hanging out over here on this terminal. Okay. Then I can say I'm done with this corner. Oh, hey, this one was J-hooked in too. All right, well, I'm going to clip the J off the end of that, and I should be able to pull that out this time. Can't get in here with the desoldering tool. Ah, stop it. There we go. And did that go loose? It did not. Okay, good. Please don't tell me you're wrapped around like that. Oh, you are! I'll be right back. This is not working for me. These will work for me. go. And this one still has a little bit of leader. I technically should have done that here. I think I still have some wire insulation I can use on that. Can I get that through that hole? Yes, I can. So I think this is the date code right here. If I'm seeing that correctly, 1049, that would imply week 10 of 1949. Could be wrong. Take that off. Okay, we can actually... Really? I might actually be even able to get rid of that insulating sleeve altogether. Because now the cap is just so much smaller. Oh, I didn't thread this through before I did that. Okay. Yep, that's good. I really should be marking off the caps as I remove them on here. I'm actually going to take a moment to save those sleeves. So let's briefly stop here for a moment, and I'm going to show you the schematic I'm working from. There we go. So this is it. This is all there is to this thing. We have 4 tubes, a 6SJ7, a 6J5, a 6V6, and this 6X5, which is operating here in the power supply. Remember that giant 1 microfarad cap? That lives right here. Note lack of polarity on it. So this here would be our multi-stage capacitors. So there's one hiding there. There was another one hiding there. Was that the only 2 there? And when it comes to the diagrams, so there's that cap I was talking about, the 1 microfarad paper capacitor. The rest of them, what happened there? Where'd you go? There you go. There's that one shielded capacitor I was talking about. Now there's a throwback. Yeah, I'm in the VC channel over on /net. It's still very active. I can't say it's openly supported by the Vintage Computer Federation, but I use it a lot more than Discord. So this is the cap list normally this would require. There's our 3 electrolytic capacitors hanging down here, which is strange. EC2 is very strange. So you can clearly see our 2 multi-stage, and then we have EC2 that's hiding right there. EC2 is this one right here, which looks like a wax paper. So that one there took me for a bit of a ride. That one's going to be an interesting one to deal with. Okay, so let's deal with this monster cap back here. A 0.5 microfarad 400, which I believe we're going to swap out with a metal film as well. No, there it is. So 0.5 microfarads, 400 volts, DC. Again, polarity is noted on this. I've just, not done that. But here's the situation. The cap is massive, and this metal film is not. So this is why I've been salvaging all of these leads as I've been going through them, because there will be a couple of times here where I'm just going to have to extend the leads. This will be fun. I'm used to doing this with much lighter gauge wire, not with this stuff. So what I did there is I J-hooked that, and then I just kind of used these to just clamp them together, and I'm going to solder that, and that's going to become now twice the length. And I'll now do that on the other side. What I'm trying to do here is ensure a solid mechanical bond. And not like that, where I think I just cut it off. I did. All right. Okay, give me a moment. I got to work a little bit off camera. There, now I'm just going to solder those together. And we will reuse these insulating sleeves. Okay, so that's now ready to go in. Now I have to get the old cap out of here. Thankfully, right now, one of the sides on this here is free moving. You can't see this. All one of these leads are currently free moving on the cap because it's supposed to go to ground. You know what's funny? This iron, for as much as I love it, and even though I've done the copper wire trick here for a heating element, like as per Mr. Carlson, because this saves a hell of a lot of money, I can't tell if this is copper-plated steel or if this is just pure copper. Anything that's grounded onto this chassis right now, this iron is not powerful enough. I have to go and dig around to see where my big 300-watt lipstick iron is, because that will do it. This, however, will not. Okay, where are you hooked? You are J-hooked right there. So I'm going to try and see if I can snip off the portion of lead I can see, or just straighten it so I can pull it out. Oh, I was J-hooking, undoing a resistor, not the actual cap. Damn. But that cleaned up almost the whole hole, so I can actually grab it now. Almost grab it. Come on. What I'm trying to avoid here is just snipping the cap lead off right at the terminal, because then I got this little like ring of component lead that's just hanging there. Either I have to then remove it and I have nothing to grab onto, or it'll just hang around there and cause me grief later. There, I think I got it. I sure do. Look at the size of this beast. Is there a date code on this one as well? No. And again, note the stripe on this side here. So this would have been the negative side. Will this actually complain if I ground it somewhere else? You know what? I won't even bother. I won't even risk that. No. Can I? Okay, I will do that. So I'll take this one back off and I'll put the longer tube back on there. There. Now I gotta figure out how to feed it back through there. It's in. Now I'll use the pliers to compress it onto the terminal. Come on. There we go. There. And now I can solder that back. There was no, there wasn't. Okay. So I'm just going to tuck that down over here with the other leads. I have photographs of how everything was wired initially, as well as I had all those schematics, so I know what goes where. Okay, so that's that. Let's take care of this sucker here. 0.02 600 volts. 0.02 600. These ones right here. Are you wrapped around? You sure are. Yeah, this one's giving me grief. I break this one up. Yes. Now it comes. And the tab's open. Good. Who makes this one? Sangamo. And again, polarity was noted on that. Where's that Sangamo? Is that long? Oh, I don't know if that's long enough. Ooh. That was J-hooked. Is that another one that's aftermarket? Okay, yeah, this one's too short as well. So I'm going to have to, again, extend the lead. So there's our extension. Now I'm just going to solder that on there. Is this not scrolling on me? No, it is scrolling on me. Okay, good. That'll do a hell of a lot better. I think now it's just too long. Well, I got a sleeve for that. That'll do. There. Another one down. What else do I got buried in here? Right. This one here. It's like 1025. So this one here is polarity sensitive. This shows up as EC2 on the schematic. I want to look at that one. That was EC2 1025. Shut up, OCR. Let me move around. There we go. EC2. There's EC1, EC3. Where is EC2? Oh, I know. Where is it attached? It is attached to pin... That's a ground. That's pin 8 on the 6J5. Pin 8. There's EC2 hanging out right there. You know what? That doesn't technically note polarity, but it's an electrolytic capacitor, so... Oh God, don't tell me that one there's a bipolar as well. You know what? If it lists polarity on the cap, I'm gonna go with that. The only way to find out if that's true is to unhook and remove the cap. So we're gonna go from lead 8. I'm just gonna bend that back and see if I can get the cap out. I'm gonna take solder out of there first. Get these out of the way. Gives me a better idea of what I'm working with. Thick wire too. There we go. Yeah, I want to pull the solder out of there. I don't see a grounding mark. Right, what's this? Posi! It actually states posi right there. So yes, this is a polarized cap. Thank God. Can I add some more light? Not too much light. There we go. There's a lot happening at this terminal. So, there we go. Gudeman. Gudeman? Alright, sure. But yeah, this side here does state posi. It's really difficult to see, but it says posi. So we're going to, that is presumably positive. So I'm going to take the sleeve off because I'm going to need that. Go. And then we'll take the cap, which is over here, and these leads are absolutely way too short. So again, we're going to have to extend them. I don't even think this is going to be long enough. We're going to have to go with different copper wire. I shall dig into my bundle of spare wire. I shall very carefully solder this as to not damage the cap. So I need basically just half the damn wire. I could have gotten an axial capacitor for this, but it would have cost so much more money. Okay, so how am I going to... I will have to insulate this. Let me see here. And I'm just taking wire sleeves. That might work, yeah. This will work. Okay. Okay, so that one's done. It's like the one lytic that I can do. Now I have these ones which are all clustered way the heck into here. None of these are going to be fun. But at least they're all somewhat on the front. Can I move this out of the way? That's coax, kind of. There's a .002600 here. How is that? Is that J hooked in as well? It is, I think. Or, ooh, don't tell me they've... Oh. I think what they've done with this cap here is that the lead goes all the way through to here. If that's the case, I have no choice but to cut it off right there. Okay, we'll deal with these wax papers over here first then. .0001/600. Don't need that. .02, no. .001. Uh-oh, is it one of these? Yes. .0001600. Which means not only do we deal with a significantly smaller cap, we have comically tiny leads. So again, I'm going to have to make extensions for this. don't think I have enough cap lead material. This stuff's kind of overkill. This is going to look stupid. Okay, solder that side. One. Can I? No, it's going to be a stretch. I will have to do long on each ones and trim it. There we go. There, now we have a usable amount of leads for these caps. Or at least for this one. Now I gotta take the old one out. That's wrapped around, I can see that, even though there's a bunch of solder still on it. Oh, that one's gonna be hard to get out. Buried. You, watching from this camera, will not see this. I do apologize. I wonder if you can stream from like a GoPro attached to your head or something. No, even then, like, it's still too much. God, it's almost like I wish Google Glass was useful. Oh, this is J-hooked as well. Oh yeah, someone's been in here before. This was J-hooked. And like I was saying before, like you clip the lead and you leave a little ring of the old lead in there. That's there. So someone's been here. So I got to get that out of there. There. So I'm just going to take all the solder off this one terminal because I got to change this cap too. Let's see. Oh yeah, there you are. J-hooked as well. No, actually, it's hard to tell. Someone's been in here before. Get that out of there. Ah, there's more clipped leads hiding in here. Okay, so I'm going to tack this cap in and solder it from this side. I'm going to leave this open so that when I do this cap here, I don't have to like desolder that again. There. I will steal that cap lead. And you are a .002600 as well. So unhook you if I can. Nope, I can't. All right, you're permanent. So I'm gonna instead cut you free and clear the hole. There you go, capacitor, be free. That was a .002, there's 001, 0001. That's interesting. Hold on a second. Alright, so you go in there. That's a dry joint there. I can see you. You need a bit more solder. A bit more heat. There. That's a lot better. What else we got in here? We have a .001600, which is a decoupler for the pickup, which is another one of those, which is the other one of those. Sorry. Saving that. Again, just extending the leads so I can actually use the cap. Yeah, we'll use that one. Okay. What am I doing? It's over here. Ah. And now I can take that cap off. Oh God, there's multiple items going in over here. I'm gonna have to basically rebuild this. You can just barely see it. So, Can I make this work? It's going to be fuzzy. So I have this cap, this resistor all going to this terminal. You won't be able to see a single part of this. But what I'm going to do is I'm going to take out this cap first, desolder that, and then I can also get this ready to be switched out as well. There's one. These ones aren't going to be fun at all because I can see how they're bent over. I'm going to have to just trim you there. Okay, and that leaves me with that. Oh, wait a minute. Yes, 0.001. Your soldering tool is full again. Okay. No, that's just too short. Oh, that's annoying. Just a little bit more and I can make that fit in there. There we go. I just need a tiny bit of solder over here. There. Okay. That was a bit of a stretch. Like, oh, that was close. Ha ha. Good minds think alike. Okay, so you are a .0001. I only have one of you, and again, it's a tiny little stupid cap. There we go. I think I'm out of... Oh, no, I still got some leads. Do I have to start stealing leads off of old caps? Great. No, I'm going to do that as like a last resort, because that's just nuts. Get that hook ready. Get the cap ready. So I almost don't even need to put another lead on this one. It just needs to go from there across, but I will have to put an insulating tube. No, that's kind of sloppy. I gotta put a lead on that. This would have helped if I hadn't have just hooked it in over here. Let me unhook this and put this back on the bench. There we go. Come on. I just got you folded over before. There. No. Get out of here. There we go. There we go. All right, I think we have 2 caps left at this point. Yes, we do have 2 left. So I got this stupid shielded one still, which was the .01. This one here, the original one is shielded. The new one is not. But like I said before, because that cap is way the heck out here, if it turns out that I am running into a problem where it needs to be shielded, it's not like I have to go dig into this crap right here. So, that's at least a little bit of a relief. But I'll leave myself a little bit of a mental reminder by leaving that ground there. I'm just going to clip that lead and leave it loose. I'm sure someone's going to complain about that. Let's not have that wire come loose. And I have this one up here. think I see it. I think it's you that I have to cut. And it was. There we go. Where's the other half of that hook? Okay, it's out. That was... Oh, yeah, you're just falling apart on me. Wax. Yeah, 0.01. Try and make this one a little bit cleaner than the others, just in case I do have to come back to it, or at least see what value I used. You are not tight on that terminal strip. There. No, you're still just... Come on. There. There's that one there, which leaves us with one more cap that we can do today, which is this red one here, which I'm like 90% certain is not original, the Tiny Chief. Okay, 0.02, 0.02. Hold on a second. These are the... what did I say the Sangamos were? Yes, 0.02. Okay. There was a moment of panic there because I thought it was 0.002. Hold on. Panic. Where's the other one? Okay, we had these. Okay, 0.002. Oh, no. This one's supposed to be a .002, not a .02. Oh, hell. Okay, I'll have to deal with that later. But I know that's 0.02 there and 0.02 there. Okay. Maybe we'll come back to that once we're done here. We'll see. At least it's not buried. Actually, what was that one doing? It's on that. Is that just a decoupling capacitor? There's the wafer. We were looking for a cap between. Oh, yay. The terminal strip isn't labeled. Or the contacts. Where the heck did this go? It ties in with that .0001. Oh, which could be anywhere. Oh, wait. I know. .0001 is C6. Was that the only one? Or is that .001? Ah, confused. .001. Let's try with these ones first. There's one. Oh. Well, the thing is, DigiKey actually, if you put it in microfarads for some of these values, it would come back as picofarads. And it'd be like, then I'd have to do the math to verify. Not saying I didn't do the math. I did the math and still got it wrong. Okay, we're looking for either C1 or Oh, I should have taken better photos of this before. Yeah, so C1 or C6. There's the wafer. C1, and there's C6 right there. Okay, so, was that just really, wait, that was ground, right? What's going on here? So either, it's going to throw switch shown in record position. All right. Okay. Doing a lot of gear. You know what's interesting with this here? For how many capacitors are in this? I have a Grundig multi-band radio from like 10 years later, which has fewer caps than this damn thing. I've seen maybe 3 or 4 wire recorders in my life. Usually they're not too expensive, anywhere between like $80 to $200. This one's not in museum condition. That's why I'm not doing like a museum restoration on this. I just want to see it work. Okay, I gotta go refer to someone else on this one here. It may be doing decoupling. It may also just be working with the coil. Oh God, this is a nightmare. It does come out of the coil. Cripes. C4, da. Oh, this will be fun. Alright, well, I'm just going to deal with that afterwards to see if I have a replacement for that. Where the heck is it? There it is. Okay, so we'll finish with the Tiny Chief. Which, as I kind of suspected, is J-hooked in. That one's clear. And that one's also. All right, fine. Cornell Dublier. Dublier? Now, when I'm done with this here, I'm also going to have to go through it with compressed air and a visual inspection to make sure that I haven't allowed solder to get into places I don't want it to. There's one. Okay, one lead, two leads, and technically we were supposed to be done by now, but now we gotta deal with this. So this is not a back. Oh, what's this got Bob's bits going on here? Yeah. Anyways, so the Sangamos here are a plastic enclosure, 0.002600. This is almost certainly going to be a wax, or not a wax paper, but it's going to be a paper type capacitor. Even if it's in a plastic enclosure, you can't trust these. And even when I was going through, this was testing bad. So I can't even put this back in. Do I have... I'm going to have to move this out of the way for a minute. Go into my overflowing pile of capacitors here. Do I have a 0.002? 0.1? No, no. No. No, no. No, 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 no. This isn't looking good. No, no. Oh, this isn't looking good. 0.01, 0.01. Oh, I got bad news for us, folks. Oh, wait, what's these? No. God, could I replace it with a disc? That's a 0.01. Actually, can I replace it with a disc? Where is cap testing? What is that showing up as? Because is that 0.01 picofarads or 0.01 microfarads? No. That won't do. Drats! Do I not have anything else in here? I think we're having... Oh, this is a miserable way to end a video. Alright, let's just take a look at this. If it's just a decoupling cap, we might be able to get away with it. But if it's actually part of that oscillator, it will have to be changed. Okay, where was I? I was heading over to you. Why is speaker highlighted? Interesting. Where is that going to? Where is C6? That goes to ground. No. No. Like if it was the tube sockets, this would be so much easier to work with. The tube sockets are easy to work with. I'm trying to figure out exactly where this cap is, judging by the wafers. And the wafers aren't labeled at all. So I'm having to figure out, where are you? It may be either C4. It's looking a hell of a lot like it's C4, which is kind of lousy. So it is part of the oscillator coil. All right. Well, that's about all we can do then. I got to start looking around then. I got to double check on this. Let's see if I can get this set up here. So what I tried kind of to do today here is that we had a mountain of wax paper and plastic encapsulated paper capacitors. We had to change them all out for me to continue on in this wire recorder project. We didn't do any of the multi-staged lytics because I've already taken those out. I have to cut those in half and I got to restuff those. And I have one here which I got to work on subbing as well. Other than that, we got everything except for one capacitor done reliably. So I am going to consider this pretty much it for the remainder of this video. That's it. I do hope you enjoyed just kind of watching me fight with this. Point-to-point soldering with tube electronics can be both a challenge and kind of exciting at the same time. You get to see some pretty seriously crazy hack work that ultimately ends up working, and you're not really sure how it works, but it does. I hope you all enjoyed this stream. For those of you who came in here and have already dropped out, I do hope there was at least something here that you saw. For those of you who have been hanging around in the chat, thank you for hanging around. All right, and with that, I want you to have a good weekend. How much ever is left of it. I know some people out in Europe, it's pretty late now. But have a good night, have a good day, have a good afternoon. It's 1 o'clock here. Take care, everyone.